All right, let's talk about something that's like the bedrock of trigonometry, quadrantal angles. The best way to think about them? They're basically the compass points on the unit circle. North, south, east, west. If you can get these down, trust me, the rest of trig starts to make a whole lot more sense. So let's just jump right in. Okay, so you're probably familiar with the four quadrants on a graph, right? You've got quadrant 1, 2, 3, and 4. Simple enough. But here's a weird thought. Some angles don't actually belong to any of those quadrants. So where could they possibly be hiding? Well, the answer is actually pretty simple. They're not hiding in a quadrant. They live right on the lines themselves. They're on the x and y axes. And these are our quadrantal angles, the compass points of our whole trigonometric map. So let's get the official definition out of the way. A quadrantal angle, it's just an angle where its final side, what we call the terminal side, lands perfectly on either the x-axis or the y-axis. There's no in between, it's not almost on the line, it's perfectly on it. Think of it like a compass needle, pointing directly east, north, west, or south. That's it. Okay, now, before we move on, I need you to pause and really lock this next part into your brain. Seriously, it is the absolute number one most important rule for the entire unit circle. Ready? For any angle, the cosine value is just the x-coordinate. And the sine value? That's just the y-coordinate. Cosine is x, sine is y. That's the whole game. If you remember that one little thing, it honestly unlocks everything else. Just take a look at this table. It lays it all out perfectly. Let's start at 0 degrees. The point on the circle is 1, 0. And since cosine is x and sine is y, well, cos of 0 has to be 1, and sine of 0 has to be 0. See? Now let's go up to 90 degrees. The point there is 0, 1. So what does that mean? Cos of 90 is 0, and sine of 90 is 1. The same pattern just keeps going all the way around the circle. You see what's happening? You're not actually memorizing a bunch of random values. You're just reading coordinates off a map. And here's the real kicker. These 4 points are the most important ones because they're where sine and cosine hit their highest points, their lowest points, and where they cross 0. They're the critical turning points for the whole system. But wait a second. You probably noticed something a little weird in that last column for tangent, right? We've got a couple of zeros, which makes sense, but then we've got this word undefined. What on earth does that mean? And why does it only pop up in certain spots? Well, let's go back to basics for a second. Remember the core identity for tangent? It's just sine divided by cosine. And since we know sine is y and cosine is x, that means tangent is just y divided by x. The whole secret is right there, in that division. So, here's where things get interesting. Look at 90 degrees and 270 degrees. At both of those spots, the angle is sitting right on the y-axis. The coordinates are 0, 1 and 0, -1. See the problem? In both cases, the x-coordinate is 0. So when we try to calculate tangent, when we try to do y divided by x, we end up trying to divide by 0. And as you know, that's the one thing you just can't do in math. The whole system just breaks. And that's why we use the word undefined. It's not some vague, hand-wavy term. It has a very, very specific meaning in math. It means there is literally no number that can answer that question. It isn't 0, it isn't infinity, it's just a calculation that has no meaningful answer. It's like a mathematical brick wall. All right, let's put this into practice with a quick example. Say we need to find the cosine and sine of pi. First step, we just find pi, or 180 degrees, on our unit circle. Okay, got it. What's the point there? It's -1, 0. And since we know cosine is the x and sine is the y, well, cos of pi must be -1 and sine of pi must be 0. See? It's really that straightforward. Okay, now let's tackle one of those undefined cases. Let's find the tangent of pi over 2. First, we find our spot on the map. Pi over 2 is 90 degrees. The point there is 0, 1. Now we pull out our tangent formula, y over x, we plug in the numbers, and we get 1 divided by 0. Uh-oh, red flag. We can't divide by 0, so the only possible answer is undefined. Case closed. So what happens if you get thrown a curveball, like a negative angle, something like -pi? First thing, don't panic. A negative angle just means you go around the circle in the other direction, clockwise instead of counterclockwise. So if you start at 0 and go 180 degrees clockwise, where do you end up? You land in the exact same spot as if you went 180 degrees counterclockwise. You're at the point -1, 0. So the sign of -pi is exactly the same as the sign of pi. We just look at the y-coordinate, and bam, it's 0. Okay, everybody lean in for a second. I'm about to show you the single most common mistake people make with this stuff. This is the one thing that trips students up on tests all the time, so you're going to want to pay close attention to this. Here it is, people. Mix up undefined and zero. It's so easy to do, but they are worlds apart. Writing that the tangent of pi over 2 equals 0, that's just flat out wrong. 0 is a number. It's a real value. Undefined means there is no value. Think about it this way. Tangent is a fraction, right? A fraction is 0 only when the top part, the numerator, is 0. For tangent, that's when sine is 0, which happens at 0 and pi. But when the bottom part, the denominator, is 0, that's when it's undefined. And that happens when cosine is 0. It's a critical difference. Always remember that.
So you might be thinking, okay, I get it, but why are we so obsessed with just these 4 points? It's a fair question. The reason is because these 4 points are the foundation for anything that deals with direction. And the perfect real-world example? Navigation.
I mean, think about it. Our 4 quadrantal angles are literally the cardinal directions on a compass. 0 degrees is east, 90 is north, 180 is west, and 270 is south. When a GPS, or any navigation system, figures out where you're going, it breaks your movement down into 2 parts, an east-west component and a north-south component. And guess what those are? Cosine and sine. So if you're driving due north, all of your movement is north-south, right? Your east-west movement is 0, and that's exactly why the cosine of 90 degrees is 0. These angles represent pure movement in one direction. So let's recap. We've figured out that these 4 points are like the anchors of our entire trigonometric world. They're the fixed points that define the highest values, the lowest values, and the zero crossings. So that leaves us with one big final question. Now that we've mastered these 4 anchor points, how do we use them to map out all the other points, the infinite number of angles that lie in between them? Because answering that question is the real key to understanding all the amazing waves and cycles that trigonometry can describe.